There's one other feature I want to go into a little bit more that we do on the front end, which bears a little bit more discussion. That's what we're terming the concept of collections. Now, what I mean by collections, if you imagine we've identified our anomalies, this is great, we've correlated the anomalies, we've got a brilliant list of really, really helpful stuff that's helped you diagnose an outage. That's great. Imagine 6 months down the line, you have exactly the same problem again, but you can't remember what you did the first time to actually capture this information. This information is only useful to you right now. Wouldn't it be cool if we had a way of actually making this insight that you've gathered from your incident more useful down the line? So what we thought would be cool is with Inoculus, once you've identified your useful results, if you can save them for later. You can add them to a collection, you can write some notes on the collection to say, oh, this was that super bad outage when the site melted. And it lets you kind of store that knowledge away, so next time you have to look at it, you have that there. But this is good up to a point, but now what we essentially have is a list of useful stuff. This isn't really any more useful than writing it down in a notebook on your desk. You still have to go through your list and figure out which of the millions of notes you've written are actually relevant to what you're looking at. But there's a good thing we can do here as well. What we do in Oculus is we actually index the collections you store in Elasticsearch. What that then means is whenever you run a search in Elasticsearch, as well as looking at the metrics index to correlate with all your current data, it will also look at all of your saved collections and correlate with that as well. So if you imagine you had a particular outage where you had massive spikes in Apache requests per second because Googlebot crawled you and it blew the crap out of your site. You've stored that data away, you've made a note, oh, this was Googlebot, this looks bad, it was a bit nasty, this is what we did to fix it. 6 months down the line, you have somebody new who started in your organization and doesn't have that memory, that kind of operational memory to know what the incident was. This looks really scary. So what will then happen is if they search for the anomalies picked up by Skyline, they search for Inoculus. Oculus will then tell you, oh, hey, this looks awfully like that thing that happened that time, and here are all the notes you wrote in it. So it's kind of helping you capture that operational awareness and also store it in a way that's actually going to be meaningful to you when you've forgotten what it was you wrote in the first place.
So this was the reason, before we get into the demo, we just want to talk a little bit about how this came to be. The reason, so this, we practice, at Etsy we do DevOps, but the thing is, like, I'm not an ops guy, I'm a developer, and Cowie is not a developer, he's an ops guy, and the fact that we were able to do this, really, I think, is a testament to the way DevOps should be done, and it's the way we do it at Etsy.
Yeah, it gave us the agility we were working, basically let us play to our strengths, but also lean on each other for support. So for example, to give a couple of real examples, we got Abe a server to run Skyline on. It turned out that server didn't quite have beefy enough CPUs to handle all the algorithms we were running. So Abe was able to just come to me and say, hey Cowie, can I have a new server? And I was able to give it to him. Likewise, when I discovered that my JavaScript wasn't quite as good as I thought it was, I was able to go to Abe and lean on him for some coding support. Now, if we'd been working in a much more heavily structured, procedurally driven kind of corporate company, this would have been a lot more difficult to achieve. We'd have had to go through, requisition requests. We'd have had to go through change control, committees, all those kind of horrible words that nobody wants to be involved with. But because we had effectively, as the kind of canonical DevOps definition says, as we were removing these barriers between dev and ops, we were able to work really, really closely together. And honestly, if we hadn't had that flexibility and that kind of skills crossover, I don't think we'd have been able to do this as effectively as we did.
And it's not even just the flexibility, it's the fact that we were able to recognize an ops need and then develop a tool to fix it, which is a thing everyone should be doing. But if you have ops guys who don't code, you're not going to be able to fix these problems that we keep coming to Velocity to complain about.
Be nice to your ops.
And of course, another challenge of that was helped by the way we do DevOps at Etsy was that we didn't even live on the same continent. So that, yeah. And before we get to the demo and the questions, we want to just thank a couple of folks. So Dr. Neil Gunther from Perf Dynamics and Brooke Arpot from Facebook really helped out on the Skyline side of things.
Yeah, and I want to give a special shout out to Brian Whitman from EchoNest. Brian did a talk at Velocity London last year. EchoNest do sort of music matching effectively. And they generate a fingerprint from their music and they use that to tell you this is all the other similar music. And I was sat in the audience, and if you ask some of my colleagues, they'll testify how excited I got about this when I came up with the idea of how cool would it be if we could do this for graphs. And that was very much the genesis of the entire idea behind Oculus.
And of course, our lovely managers, Seth Walker and Rafe Colburn, and MCR, Mike and Betsy, and John Allspaw were fantastic in their support and encouragement. And these are open sourced. You can check them out. Do you guys want to see them? You want to check them out? Yeah, OK. So we're going to go ahead and show you these tools with production
Let's
data.
just turn display mirroring on back here so we can actually see what we're doing here. Mirror displays. There we go.
OK, we're connected to prod. Awesome. OK, so this is Skyline. You're looking at it. These are all the anomalous metrics you can see. And you can see we include the two graphs, right? And those are the two durations of the views. You can see at the top there is the hour-long view, and the bottom is the 24-hour-long view. Because sometimes what something looks like anomalous with respect to 1 hour isn't so anomalous with respect to what is normal over a longer duration. And we've got all our metrics here. So at the top here, these are the ganglia metrics.
This is our real production data, by the way. This isn't a demo we staged for you.
And so you can see at the right side of the graph, you can see spikes or dips in the time series, and those are the anomalies. And the red line you see there, that's the actual data point that triggered detection. And that's also listed in this column here. And so we have the red line there, so you can kind of compare the anomalous data point with the rest of the data very easily. And this will update every 30 seconds. It'll get the new JSON file that was written out by the Skyline backend. And so the process is all you do is you kind of sit here and you scroll through things and you say, oh, like, that doesn't look good, or that's an anomaly. And and so here's an example. This is a seasonal graph that we don't actually count for yet. These are pretty annoying. It's more noise in Skyline. So we're working on algorithms to get this. We have a question. Yeah.
So it looks like you don't actually sort of rank the anomalies. Is that true?
So we don't rank the anomalies, and I can go into that. We originally did. We originally would rank them by how anomalous they were and sort them and show the most anomalous ones at the top, which is something that you would expect to happen because those are the ones you want to see, as opposed to kind of scrolling through everything willy-nilly by alphabet. But the problem is that assumes that imposes an opinion on the way you want to do algorithms. If you do something like that, you have to use forecasting techniques. You have to, and you have to return an error, right, from what your prediction was and what the actual data point was. And those techniques are pretty robust. Like they do work, and possibly we should be using them and not this consensus model. But the problem with the consensus model is that if you were to try to see how anomalous a metric is with respect to all of them, they're not on the same scale. They're completely different numbers. They don't really mean anything. So we kind of black box it and just return true or false, whether they think it is or not. So if we were to try to do this with a consensus model, we would have to only weight by one algorithm, right? Because we can sort relative to a single margin of error. We can't really sort across different algorithms and different margins of error. And if we wanted to do that, we would have to probably throw away the consensus model, which may be something we end up doing, or it may not be. So we're sticking for consensus for now, but that's definitely a discussion to have later on. And so you can see all these. These are all your anomalies, and then once you found one that looks intriguing, which we can find one. All right, so that looks pretty bad. Whatever that is, looks like our customer service PHP time is spiking right now, which doesn't seem good. You can do two things. You can click and get the actual Graphite graph, right? Because this is coming straight from Graphite, and this is your normal Graphite API that you can then use to format it, do whatever you want with it that you're used to, right? Say I want JSON all of this, I can just easily.
We're just typing and format equals JSON.
Right, and so this is just a regular Graphite. You can do whatever you want. And then if you want to then go ahead and check out what that metric looks like in Oculus, you would click through the little arrow there, and then it'll immediately do an Oculus search for metrics that are correlated.
Yeah. Now I have to apologize for the fact there's no neat little Ajax spinner here. That's because I'm not very good at JavaScript. It will be there soon.
You have a question?
Sure. So what percentage approximately of your real outages and incidents, say over the last quarter, were not reflected in this?
So the question was, what percentages of our outages and incidences in the last quarter were not reflected in this?
It's actually I'm going to slightly cheat on the answer to that one because this is a relatively new tool. It was released internally about a month ago, about roughly 1 month. It was open sourced about a week ago. So over the last quarter, not that many. We're now basically starting to see things. There was one, I think the day we launched it internally, we noticed a spike on one of our DB shards, and we were able to basically see whether that was affecting just the one shard or whether it was something that was affecting all of them.
And what does happen actually fairly often is that we'll be looking through Skyline and we will detect something, but it will turn out that it has already been detected by another monitoring tool, whether it's a dashboard or whether it's someone that's expecting it, like, oh yeah, we just pushed this change to this feature, we're expecting that spike. Or yeah, this is a problem that we got an alert on 5 minutes ago. So we're not quite the front line, like you don't want to use this for your only monitoring. Again, this is just a step into in the direction of how to do this. It is not by any means a complete mature tool. So yeah.
Yeah. So this is the Oculus page. It's chopping off the left-hand side slightly there. So apologies for that. So this is what we think is correlated. The metric we search for has a score of 0, which it should do because it should be identical. And what we're then getting is this is actually very similar to the customer service stats signed in count. So this is differing between signed in and signed out users. So we're actually seeing exactly the same stats, the exact same increase across signed in and signed out users. If we scroll down, we'll see we've got some thrift banner timers. We've got some other stuff down here. And what we may end up deciding is actually that we don't really care what the timers are doing. That's not actually that interesting to us at the moment. So what we can do, this is where the tokenizing by periods comes in, because we can now filter by the individual component of the graphite namespace. So we can say, well, let's filter out timers. We'll run this search again and see what we come back with. It'll take a few seconds to run because of computers. So now we've got our results. We're filtering out timers. Let me just zoom out slightly here so you can actually see it. Apologies, it's chopping it off. So that gives us a few more. That's eliminated timers now, and it's giving us a bunch more interesting metrics to look at. So we've captured that. Let's say we just want to capture these 2 customer service stats at the top because they're really interesting to us and they're quite indicative of something that broke. So we can add these to our collection. We'll add them at the side there. We're then going to save this collection. Let me just copy the name of this so we can search for it in a second. One second. There we go. We'll call the collection name super important. And we'll say this was bad. So now save that away. This will be indexed in Elasticsearch, and it just gives you a little view of the collection. What will happen now, if we search for the same thing again, after a little bit of crunching, it should give us the same results as before because we haven't actually moved on time yet. All the graphs still look the same. But when the results come through, you can see why we had to drop it from 4 to 5 minutes now, because it still takes quite long even with all the performance improvements. Okay, so now what we're seeing at the top here is, as well as our normal results, we're actually matching metrics that were saved in, this is actually matching metrics saved in 2 collections. It's actually 1 collection. It's that's an error in my JavaScript. I told you I wasn't good at it. So we can see the matching metrics here. We've got customer service stats all count and customer service stats signed in. We can then click through to that and we can see that these are the saved metrics and we can see the notes we wrote. So that's kind of given us that, it's captured that knowledge that we had at the time of the incident. It's then stored it away in a useful form that we can actually identify later without having to remember that it existed in the first place. As well as clicking through from Skyline, you can also manually search for stuff in Oculus. At the moment, I'm working on a better metric picker. At the moment, you have to type the full name of the metric in, which is a little unwieldy, but it does the job. So this is searching for example, Apache requests per second on a production web server. So what we'd expect to see here is a whole bunch of other metrics from other web servers, which we do, which is good, because if we didn't, it would be broken. So yeah, a bunch of stuff from other web servers. This didn't match any saved collections. Those weren't correlated to any of our saved sort of outage fingerprints or incident fingerprints, if you will. There's one last feature I want to demo. I'm not going to pretend there's actually an awesome operational reason for having this. I saw a demo of Google doing something similar, and I really wanted to put it in Oculus. So it is, and I'm going to show you. And it will let you draw your query. If you want to search for a graph, this is pure. I'm just making this up as I go along now. Say you happen to walk past the dashboard and you happen to notice an anomalous graph, but somebody forgot to label the dashboard. Whatever shall we do? But you can remember the shape of the graph. So what we can do here is we can say, let's look for graphs that look sort of like that. So then, crunchity crunch. Hopefully, it will come back with something that looks sort of similar. And if it doesn't, I'm going to look silly. God, you can feel the suspense, can't you? Hooray, it worked. So yeah, I'm not going to pretend that's an awesomely useful operational feature, but I thought it was kind of cool and I put it there. So thank you for the applause. So that's basically the demo. As I mentioned, these were open sourced about a week ago. You can find Oculus and Skyline on the Etsy GitHub repository. They're MIT licensed. You can do what you want with the code. We welcome pull requests, we welcome ideas. As Abe mentioned, one of the focuses for Skyline is more robust algorithms. With Oculus, you may want to clean up the code a little bit. It was written by an ops guy. I'm reasonably okay at coding, but I'm not a professional developer. So you might look at my code and think it's horrible. I'll more than happily accept that from you if you clean it up.
So we do have some time for questions.
Yeah.
If you want to.
Any questions from anyone? Or suggestions? Anything?
Have you thought about taking into account past correlations? So if you know two things correlated in the past, have you thought about prioritizing them?
So the question was, have we thought about past correlations? We're slightly, well, two-part answer. One, you can sort of do that with collections. If you notice the past correlation, you can store it away and we will account for that. It's harder to do that going forwards because we're only keeping an hour's worth of data. So it's entirely possible, it's a good idea. We'd need to basically have some way of storing past data that retained it when we basically blow away the index and regenerate it. But that, yeah, it's totally something we could look at going forwards. Anyone else?
So have you tried to make your Skyline and your Oculus more like distributed fashion so that you can easily scale them?
So the question was, have we tried making Skyline and Oculus distributed so we can easily scale them? We've tried not to make it distributed as far as we could handle it. So Skyline runs on a single box, which we think is an excellent feature. We could probably, it takes 90 seconds for the throughput. That's not ideal. We would like it to take a lot less, and at this point, we would have to move to several boxes in order to do that. But we have tried delaying that problem for as long as we can, just squeezing as much juice out of a single box. Because when you start to build distributed systems, it's not as fun as building not distributed systems.
I kind of took the opposite approach to that, and Oculus actually runs on about 5 or 6 boxes, because I thought it was fun designing a distributed system. So to roughly describe that, we have the Sinatra web app runs on one server, which also stores, because we don't want to interfere with our production ganglia server, we're actually storing a separate copy of all the G metrics. Of all the RRD files. So the web app runs on that server. We have a rotating pool of 2 Elasticsearch servers. You can use as many or as little as you want. Oculus will actually work with 1, although it will still blow away your indexes if you're searching them. So 2 are recommended. And the rescue workers, that parallelizes really well. It's because it's essentially just giving it a list of keys, of keys in Redis. That parallelizes almost indefinitely, providing your Redis server can take the load. So we farm that out into batches of 500. I think there's about 200 Redis workers running at the moment. They'll grab 500 metrics at a time. They'll crunch them, shove them into Elasticsearch, and just sit there waiting for other stuff to do.
Theoretically, it wouldn't be too difficult to distribute Skyline, which is wrong because it's a distributed system. But ultimately, what you can do is, there's a Redis cluster. You can have a master-slave Redis configuration, just have multiple Redis boxes, and then just distribute the work of the analyzing, right? Because it's a simple divide and conquer algorithm. You're just taking the Redis keys and analyzing each one with respect to the ones that get assigned to it. So if you have more boxes with the same data, you could kind of farm that work out pretty easily.
Or to expand on that, I don't know if you've got to deal with global data center config, but maybe for RabbitMQ in there or something.
Sure. So that was suggestion was adding some kind of queuing system in there. That would be something you could look at as well. Yeah, if you were looking at massively scaling.
It's more technology. We don't want to do that.
Okay, so the question is actually for troubleshooting. I think the idea of getting this anomaly is really for finding out where's the wrong, right? So when you get this anomaly, how do you tell which servers have it?
So the question was, when you get an anomaly, how can you tell which servers the anomaly is actually for.
This sort of goes back to what Theo was saying earlier on, actually, about having this will give you the anomaly. It will not identify the root cause. It will not give you the magic bullet that will let you fix your problems. You still have to have the sort of awareness of what's going on in your system, how your system fits together, to know that if this metric is spiking, we'll tell you it's spiking, but we're not going to tell you what that spike's causing. Although we will tell you other graphs that did similar things, which might be the cause, but as we know, correlation doesn't always imply causation. So we're basically trying to help you figure out what's going on in your system, but it's impossible for us to literally tell you exactly this spiked graph caused this problem.
And the only clue you have is just the name of the metric. And even our metric names are really, really inconcise and inconsistent. And you don't necessarily know who is responsible for what metric. Sometimes our statsd calls aren't even handwritten, they're dynamically created, so they could be anything really. And so the strategy that we have right now is we just go into the IRC channel and say, hey guys, does anyone look like this is bad? Unless we happen to know the person responsible for it, which is a rarity.
One thing we'd quite like to look at in the future is the possibility, we haven't quite ironed out the details of how this would work, but it would be cool if we could actually use this kind of anomaly detection thing to generate Nagios alerts or whatever with kind of dynamic but meaningful thresholds and some way of presenting you with meaningful data. That does sound like quite a hard problem to solve because you're effectively trying to grab thresholds and meaning that will be correct all the time and aren't going to wake you up falsely. So it requires both a fair amount of work and also you have to have a fair amount of trust in that system to enable it, because if it could wake you up hundreds of times a night if it goes wrong.
And you don't want to rewrite Nagios. So,
Could that be partially addressed by throwing more metadata like host names and stuff into the identifiers, or does that start putting pressure on your tokens?
So the question was, could that be addressed by throwing more metadata into the identifiers?
It pretty much could.
It could be, yeah, but like statsd is simple. Like all it supports is just the name and the metric.
Yeah. So our system level metrics, the ones that come from Ganglia, they already have the host name in the metric name. It's ganglia.gangliacluster.hostname.metric. So for the system level metrics like CPU, Apache, MySQL, that's already, we already have that information in the metric name. statsd, because that's more application level metrics, that doesn't capture what host it comes from. It captures, for example, this was the page load time of the home page. That's kind of an aggregate statistic across everything that's reporting that metric. So there would potentially be the option to record, I guess, for statsd metrics, the server it came from, so you can then say, well, it looks like this was actually isolated to maybe one of the web servers as opposed to the whole pool. Yeah. Cool. More questions over there?
Yeah, question. You guys chose graphite relay as the ingest for Skyline. Why not the output for statsd itself?
Because not all of our metrics come from statsd. Partly because we also feed graphite from other sources too. We don't solely populate graphite with statsd. We have, for example, some of our chef tools will actually send a metric to graphite directly, not going through statsd. So that it just let us capture, well, two reasons. Firstly, it let us actually capture that data, and secondly, it made it easier because all of the graphite Whisper stuff, the carbon relay stuff is written in Python, and we were writing this in Python. It made it easy to basically avoid reinventing most of the code.
Another limitation with statsd is that, the advantage of having statsd is you can take more complex metrics, like percentiles over time, which you can't really do natively into graphite, right? Because you can ping Skyline directly with increment calls or set calls, but if you want to get like gauges or the more intricate things that statsd lets you do, which is partly why it's so awesome, you can't natively do that. And so
you could actually, because we have this additional listener, the listener I mentioned we use for importing Ganglia, if you actually decided that the way we did this sucks and you don't want to use relay and you want to point statsd at it, at the moment the listener takes message pack encoded metric name timestamp value. You can shove data in from any source you want. You could shove it directly in from your switches if you felt sadistic enough. Yeah. Anyone else?
Okay, let's go to lunch.
Woo!
All right.